Hello, I'm Martin Hunt, Director of Applications Engineering at Coherent Logix. Thank you for joining us today for our demonstration of HyperX technology used for virtualized view generation and fire detection. In this demo, we will be using 4 cameras with wide-angle lenses, and those are viewing this whole space. We capture the video feed on gig vision from those cameras. So the data streams to the HyperX processor over the Ethernet into this development board. The development board implements the Any World View processing to create the virtualized view, and then runs through the neural network and displays on this monitor and shows when fire is detected with the red box.
An example use case for this application is industrial environmental monitoring, such as an oil refinery. In this scenario, the placement of multiple cameras can be combined to create a virtual view and dynamic sweep of a space feeding into the fire detection network. The processing algorithm starts with gig vision packet processing from 4 raw bare camera streams and then feeds into the demosaic and ISP. Concurrently, the virtual view specification is calculated based on user, sensor, and optionally the output of the fire detection network. The geometric warp of individual tiles follows, and overlapping regions are blended. Finally, the virtual view is fed into the fire convolutional network. Now we will follow the data from the gig vision cameras down to a power over Ethernet switch. The packets are then sent across another Ethernet link to the HyperX development platform, where they are streamed into the processing flow running on the HyperX chip. The output results are sent to a HDMI out with the graphic overlay of the fire detection. Here we show the mapping of the processing algorithm to the HyperX computing fabric. The wide-angle view from each camera is shown here with the placement of each in the location of the direction of the field of view. This is the input data for the virtual view generation. In the lower left, we show the parameters for the virtual view, including X, Y, and Z position and camera pose, azimuth, and altitude, as well as camera field of view and rendering surface depth. In the view on the lower right, the virtual camera is positioned above and behind the actual cameras on the tripod, looking forward and down. No physical camera is in that location.
In this room, we have several monitors set up playing video with fire scenes. Here's one from a furnace, and here is a kerosene lamp, and here is another video being played of a car burning.
Now I will show the real-time control tool in our HX ISDE. This tool enables us to control the virtual view location in real time as the application is running. Variables in the HyperX code can be modified without interrupting the running application, such as enabling the fire detection results in the video overlay. Here we are capturing the HDMI output from the HyperX, showing the above and behind view mentioned earlier. I will interact with the real-time controls and change the field of view by zooming in, as well as raising the altitude of the virtual camera. Now we dynamically switch to a top-down bird's eye view several meters above the physical cameras, and then switch into radar mode where the azimuth is sweeping around in a circle. The data flow diagram shows the input to the fire detection convolutional network is the virtual camera view. The fire detection network is based on an inception model with 14 convolutional nodes, as described in a paper by Ganesh Shumerth. Now we will use RTC to turn on the fire detection network overlay and begin to pan the virtual view across a monitor displaying fire. we stop the pan and show that the detection window is red. Then we continue the pan around the room. The fire indicates no detection with the blue window. We continue to make a full sweep of the room, and we eventually detect fire displaying on another TV monitor of a burning car. And then we continue to sweep the room and approach a kerosene lamp with a flame. The fire detection network sees the flame. We stop the azimuth and we zoom in with the virtual field of view. And then finally, we go back to the original field of view and continue the sweep of the room. In conclusion, we have demonstrated the combination of a geometric perspective mapping and fusion algorithm and a convolutional neural network as a streaming application, all processed on the HyperX computing fabric. From 4 individual wide-angle camera streams to fire detection in a large space. HyperX is a power-efficient, high-performance, and scalable solution for end-to-end AI and computer vision applications. We have shown the combination of many image processing, computer vision, and neural network algorithms occurring concurrently. The HyperX memory network processor handles all the processing from Ethernet packet in to HDMI display out and enables low latency from sensor to screen or information. All of this with a low power utilization and low heat generation.
Thank you for joining us today for our demonstration of HyperX for virtual viewing and fire detection. Please come by our kiosk and ask us for more information. Thank you.